Hmm?
A line joining equal elevation points.
Equal elevation. What is
Yes, sir.
elevation? What do you mean by elevation?
Is a
If I'm not
reduced
wrong,
level below.
I've already given you a definition of contour and elevation as part of our leveling chapter.
These levels
But
are taken from any benchmark.
any others from regular students? What is an elevation? Is it the front face of your house or building? Generally called elevation బాగుంది elevation బాగుంది అంటాం కదా. Is that an elevation? You have to respond. Others.
Sir, don't know, sir.
Any other?
Altitude and height.
Yeah. Altitude and height with what? With reference to what?
Ground level.
You are measuring ground level. But with respect to what or with reference to what?
Mean sea level.
Yeah. Elevation at a given point on the ground surface is nothing but the height of that point on the ground with respect to a reference called as mean sea level, because mean sea level is the one with which we are going to take the elevations across the world. Okay. For every area, we'll be having a mean sea level. With respect, that mean sea level, we'll be considering it as a zero elevation. From that, you are going to measure what is the height of a given point on the Earth's surface. If you take the example of Secunderabad railway station, it is around 540 meters above mean sea level. Okay, so like that, we are going to measure the elevation of any given point on the Earth's surface with respect to a fixed mean sea level, which will be fixed for every 19 years of time. Every 19 years, there will be a change in the mean sea level based on the variations in the tide heights or tide levels of the sea level. Okay, we'll be observing for 19 years and we'll be deriving an average tide level. Based on that, we'll be deriving a mean sea level. So that mean sea level, whatever we get, we assume it to be the 0 meters. Okay. So for us, for India, where is the mean sea level located? With respect to which location in India we'll be measuring all the heights or elevations?
Bay
I
of
covered this in
Bengal.
leveling, but there's a huge gap, so you might have forgot. But do a wild guess.
Mumbai.
So we'll be measuring with the Mumbai port. Okay. Mumbai seaport is taken as the 0 meters, and whatever elevation you are measuring, what now itself I said Secunderabad railway station 540 meters is with respect to Bombay seaport. Before independence, it was with respect to Karachi port, but after independence, it was shifted to Bombay. So in India, whatever elevations we are going to measure are with respect to Bombay seaport, which is designated as 0 meters. Okay. So and the elevation values changes from place to place. Secunderabad, it may be 540. If you come back to Nampally, it may be 520. If you come back to LB Nagar, it can be 560 or 570 or 490, whatever it may be. The elevation values changes. Okay. So now let's start into the concept and why this is required. Why these elevation values are required, especially for civil engineers. What do you know? What you'll do by knowing the elevation? Is my screen
It
visible?
depends. It depends on topography and shape of the land, sir.
Okay. Is my screen visible? Is the PPT visible to you all?
No, sir.
Now?
Yes, sir.
Okay. So let's see the basic definition of contour. A contour is an imaginary line on the ground surface joining the points of equal elevation. Okay, that is, we are going to find out what points on the ground surface are having an elevation, equal elevation. Assume that 500 or 510 or 520, 530, whatever it may be the value. If you join all those points, then we term it as a contour. Okay, or in other words, it can also be defined as a line in which the ground surface is intersected by a level surface obtained by joining the points of equal elevation. So this line on the map represents a contour and is called as a contour line. Seems people are joining now. Okay. So what do you understand by the first definition? Hmm? What do you understand by the first definition? You need to be a bit active. If you don't respond, it will be demotivating for us also. So assume that these are 5 points, 6 points which are available on the ground surface, whose elevation is assume that 500. So a contour is nothing but a line joining the points of equal elevations. I'm just drawing roughly because it is not possible here to join smoothly. So assume that we are having some points like this whose elevations are given here. In the first case, you're having 1, 2, 3, 4, 5, 6 points whose elevation is 400 meters with respect to the mean sea level. So if I'm going to join all these points with a line, so this line is nothing but the contour. So it's an imaginary line joining the points of equal elevation on the ground surface. In the second case, you can see there are 3 points whose elevation is 500. So this becomes a 500-meter contour. The first one becomes a 400-meter contour. So like that, you can have many contours. Okay. But all these contours should be smooth lines. So here I am not able to draw a smooth line. So I am drawing a, what we say, I'm drawing a rough line, but it should all be a smooth line. Okay. So this can be one more contour. Similarly, in between also you can have some more contour. So it all depends how many contours will be there, will be required, and what should be the spacing between the contours, or what should be the distance between two successive contours. It all depends on the application for which you want the contour data. But in simple, again, I'm repeating, a contour is nothing but an imaginary line joining all the points of equal elevation on the ground surface. It can be in your study area, it can be in another area. A 500-meter level, a 500-meter elevation can be available in MBSR Engineering College. A 500-meter elevation can be available in Nagarkul. It can be available in Badangpet. It can be available in and around Secunderabad area also. Okay, so the value can be anywhere, but it's the imaginary line which definitely comes under one line. All these 500-meter points, if you try to join in a given area, all those will fall in the one line only. Okay, so that is the definition of contour. So what we'll be doing with this contour, or what we'll be doing with this contour map. A map consisting of only contours is called as a contour map. Okay. A topographic map also consists of contours in that, in additional to land features. But most of the cases we don't prepare a separate contour map for smaller applications. If it is a detailed contour data, if you require, then only we'll go for that. Otherwise, we'll be using the contour map, contour values or contour figures available in the topographic map prepared by the Survey of India. Okay. I'll show you one map prepared by them. So this is a topographic map of 1:25,000 scale prepared by Survey of India in 1975. Okay. In this, they'll be giving you the legend here. You can see here the contours. The contours with sub features, rocky slopes, etc. kind of thing. They have given you some figure here. This scan map is not that clear, but you'll be having the information here. So you can just zoom it and you can see the values. You can see the contours here. I'll just zoom it. Just tell me whether you are able to see any value such as 520, 530, 510. Is it visible on the screen for any of you, and 550? Please check once.
Yes, sir. Yes, sir. 550, 530.
Yes, sir.
I
530.
I want the major response from the regular students, because the laterals have already studied all this. I'm hoping that, no, I'm not saying that you should not respond laterals. You can also respond. But as you already know, I want to give a chance to regulars. So are you able to see how many values are you able to see in this screen? Rule number 30.
550.
Rule number 30. Is she available? Rule number 30. Who are there? Then questions అయినప్పుడు మీరు ఆన్సర్స్ ఇవ్వకుండా అటెండెన్స్ టైంలో ఆన్సర్ ఇస్తే మా అటెండెన్స్ వేయనమ్మా. రూల్ నెంబర్ 30 ఈజ్ దేర్. సీరియల్ చూస్తున్నాడో సినిమా చూస్తున్నాడో? రూల్ నెంబర్ 25. క్వశ్చన్ అడగంగానే కొంతమంది లెఫ్ట్ అవుతున్నారు. రూల్ నెంబర్ 49.
Sir,
Yeah, tell me what are the values you are able to see in this between 500 to 550?
uh, 500 to 550. I don't know, sir, like how to measure.
I'm not asking you to measure, Amma. I'm displaying a map on your screen and I'm asking you what are the values you are able to see. 500 to 550 మధ్య నీకు ఏం వాల్యూస్ కనిపిస్తున్నాయి అక్కడ? నువ్వు మెజర్ చేయాల్సింది ఏం లేదు, కంటిగా చూసి చెప్పు.
530.
530?
530.
Only 530? You are able to see
530 only, sir. Like
others?
Yes, sir.
530,
Sir,
510, 520.
520, 530.
530, 520, 550.
510 కనపడట్లేదు అక్కడ.
కనిపిస్తుంది సార్.
కనిపిస్తుంది సార్.
So there are 4 values here: 510, 520, 530 and 550.
Sir, 540 also, sir.
540? How come I am not able to see?
Yes, sir. Bottom, sir. Bottom is there.
Huh?
Bottom is there, sir. 540.
ఎక్కడ బాటం అమ్మా? This one?
Black color, sir. Black color.
Left bottom, sir.
లెఫ్ట్
This is
సైడ్
like
కార్నర్.
Okay, okay.
Yes,
Yeah.
sir.
This is not a contour. 540 is not a contour. It's the elevation value. It's a spot level. Okay. But you see, are you able to see some color, a different color to this line 530, 510 and remaining adjacent features? Some features are in black color. Some features are in, this is brown color. Okay. For all these numbers which are represented here, you are able to see it in a brown color, right? Okay, this is lightish brown. If you see a hard copy map, you can easily distinguish. So these are the contours. Okay, this 530, 520, 550, what we are showing here, these are the contours, and this is the output which is provided by Survey of India of doing the surveying using leveling operations. And based on these values, a civil engineer will continue his work. Okay. Suppose, take an example here. Here it is 550. Okay, this middle one. So this one is 550, this small one. This is 530. Okay. So what can we infer from this? From this point to this point, there is a difference of 20 meters. I am trying to explain you with practical application. You don't bother about understand the concept. You please don't bother about the theory part. I'll share the PPT to you. You can learn from that. I'm just trying to show you once. See, here it is 530. Here it is 550. So what can be inferred from these two? How the slope is?
Downwards.
Downwards. So I can infer that from this point, assume that this point is some Nadargul. Okay, this 550 is Nadargul, and this is 530 is Badangpet. And let us assume that this 520 is some other area nearby. Assume that it is Karmangad or whatever it may be, for example. So I can infer and tell that the elevation or the surface, ground surface is in a depressing mode from Nadargul to Badangpet and Badangpet to Mandamallamma. There is a gentle slope from Nadargul towards to the Karmanghat area. Okay. So if I want to lay a road between Karmanghat and Badangpet, how can I use a contour map now? So my elevation should be between 530 and 520 in a gentle mode only, right? That is one possibility. Otherwise, if my road level is at an elevation of 535 meters, I can do a calculation from here to here. Okay, from this point to this point, what should be the earthwork required? Okay, if my elevation is 535 meters. Okay, here it is. Sorry, if my elevation is 535 meters. So here the value is 550. So how many meters I need to dig? I need to dig.
15.
Sorry, I need to remove 15 meters. I need to reduce the elevation at this point to 15 meters, and I need to increase the elevation at this point to 15 meters. In between, you'll be having different values, right? Here it is 550, here it is 520, means somewhere you may be having 525, 530, 545, 540, 530, 535, 532, depending on the existing ground surface. So by simply overlaying these values, you can determine how much amount of earthwork is required or not. Okay. So that is a major application. I'll show you here. This is my two ends of a road. Well, this is my, what I mean to say, design RL of the road. And this is the existing contour interval. Okay. This is the existing contour. Here there is some value, here there is some value, here there is some value. All the three values are different. And this is what I want to lay my new road here. Okay. So now using these contour values, you might have some more some other contour value also here. Okay. Most of the cases, the contours follows the same shape. Okay. So if I need to bring to this level, what I need to do at this portion? Here the ground surface is more than the required elevation of my road. I need to excavate earth here, right? You can Martin Toval ikkada. But when I come to this portion,
Fill.
I should fill that. Again, when I come to this portion, I should excavate.
Remove.
So If my road extends for a kilometer or 2 kilometers and I have a contour map like this, I can determine how much amount of earthwork to be excavated, how much amount of earthwork to be filled. And whatever amount of earthwork I'm excavating, is it sufficient for me to fill at that place? If it is sufficient, well and good. If it is not sufficient, then I need to procure earth from other area in order to fill this depression. ఇక్కడ ఫిగర్ లో మీకు ఒకటే డిప్రెషన్ కనిపిస్తుంది, బట్ ఇఫ్ యూ డూ ఏ వర్క్ ఫర్ 1 kilometer 2 kilometer, you can have many depressions, you can have many excess amount. So you need to do a calculation, how much amount of excess earth is available, how much amount of earth need to be filled, and you need to prepare a budget whether it is sufficient, whatever you are excavating at that particular place along the stretch of 1 kilometer or 2 kilometers, is it sufficient to fill that area, or do I need to bring the earth from other sources using lorries and trucks, and I need to fill? So what will be the corresponding cost for all that? All those things can be made with the help of a contour map, and you need not go to the field for this purpose. Okay? Simply by seeing this topographic map and drawing this line on the contour map, on this topographic map, or if you want to extract only the contours from the topographic map, you can also do that. If you overlay these two layers, then you can easily determine how much amount of earthwork excavations and fillings are existing in the current work or in the current project. Okay? That is how you can use these contour maps for civil engineering applications. The same applies to your railway networks also. Railway lines also, you can't lay it directly on the ground surface. Some cases you need to elevate them, some cases you need to depress them. Okay. The same case applies whenever you want to go for the construction of a reservoir. Okay. So that is the major purpose of learning contouring, or that is a major purpose of contour. And without contouring and leveling, I'm telling you again, without contouring and leveling, there is going to be no civil engineering project. Okay. Whether it may be a normal house, whether it may be a road work or a rail network or a reservoir construction, okay, whatever application which involves some sort of construction, that definitely needs the values of contours and the values of leveling, or the principles of leveling. Why I'm saying principles of leveling? You are going to determine these contour values using your principles of leveling only. Using a dumpy level, an auto level, or a total station, you are going to determine what is the elevation at the required point. So you are going to do the survey in the field using a total station or a auto level or a dumpy level and a leveling staff, and then based on those values, you are going to prepare this contour map. Okay. I hope you can all recollect how you have calculated the reducer levels. You have placed the staff at one point. Then you have seen it through the auto level, wherever the line of collimation is intersecting the staff. Okay. You are noting down that staff reading 1.235 meters or 1.500 meters. And that staff reading you are subtracting from the RL of the benchmark, from the reducer level of the benchmark, to determine what is the reducer level at which you have kept the staff. That is nothing but this contour value. Okay. Is it clear?
Yes, sir.
Okay. So leveling is mandatory for you to determine the reducer levels or elevation values. Based on those elevation values, you are going to prepare the contour map like this, as is shown here in this figure. And for ease of explaining, I'm taking 400 meter, 500 meter in this figure, but you can have n number of contours. But generally, the Survey of India takes interval as 20 meters for 1:50,000 K, 1:50,000 scale. Okay. So all our contour values will have a difference of 20 meters, 500, 520, 540, 560, 580, 600, 620, like that. So depending on the scale, again, the contour interval reduces. And depending on the area also. Suppose if you take a flat area, okay, can I go for a higher interval or a lower interval? Lower interval, because if you take higher interval, if the area is flat, then you will not be getting any variations. You will not be able to observe any variations. The minor variations which are available will get subtracted. So if you go for a lower interval, so 500, 501, 502, 503, then you will be able to understand how the variations in the ground surface is there. Okay. I'll just give you an example again here. I'm just drawing the rough sketch of, assume the levels obtained from your leveling exercise. These are the problems in online teaching. If it is offline class, then we can simply draw a line, rough line on the board and can explain. So assume that these are the levels which I got from the leveling experiment which I have done. These are some values. So assume that it's a flat surface and we are taking at an interval of 20 meters. So from first line to second line 20 meters, then second line to third line 20 meters like that. So you can see there is a gentle slope. The variation in the elevation of first line and second line is less. Similarly, second line, third line is less. Third line and fourth line is less. So can you find out? Can you find out any? Can you infer any meaning from this? If I want to do any precise work, highly impossible. Simply by seeing these contour values, we'll say that the surface is flat because the variation is very less. But if I take a contour value at a lesser elevation of 1 meter and 2 meter, assume that I'm getting the RL values like this. So can you infer now? From here to here, it is like this. From here to here again, it is like this. So at some point in between the two lines of 20 meters, there is a depression from the second concept. But in the first concept, what you're able to say? You're able to say that the slope is flat. The ground surface is almost flat. But if you go into minor, okay, minor inspection, you can say that at some point, assume that this is 5 meters, 10 meters, to 15 meters, 20 meters. So at 10 meters, there is a depression when compared to the 0 meters or 20 meters. But if you see from 5 to 10 meters, again, it is gentle only, not that much slope. Okay. So if you want to do a detailed analysis for a flatter areas or the surface where the elevation is almost equal in the variation of only 1 meter or 2 meters, then you need to go for a lower contour intervals. Okay. If the overall difference is only 10 meters or 20 meters, then definitely you need to go for 1, 2 meters contour intervals. So in order to study the area very clearly. If there's an elevation difference of 50 to 60 meters, then you need not go. You can go for 20 meters or 30 meters because you're able to see the difference clearly. Okay. So that is the purpose of this. So a contour map is nothing but a line map consisting of contour lines. A contour map is different from a topographic map. Please keep that in mind. Generally, these questions come as part of your gate also. A contour map only consists of the contours in a particular area. A topographic map consists of land features, urban settlements, water bodies, contours, forest areas, everything. Okay. From this figure, you can see you have all the features existing in this particular area. This belongs to this is the watershed boundary of our Sarvanagar area, and this brown, white, purple color are all the water bodies, okay, and red color is the drainage pattern. You can see every feature in this. The water bodies are existing. This is the water body. This is a water body. This is also water body, but there was no water at that time when survey was done. Okay, this is the road network. You can see this is the road which is going. This is the Gurramgada protected forest area. Okay, and this is your Dilshuk Nagar area and Saidabad area. So a topographic map consists of all features existing on the ground surface. A contour map consists of only contour values. Okay, no other features. And if you cut the contour, you'll be able to see the both the plan and section. And I hope a plan and section are covered already in your engineering graphics. What is a plan and what is a section? Hmm? What is a section? సెక్షన్ అంటే ఏంటమ్మా?
Part, sir.
Huh? What do you mean by section? What is the purpose of section of solids?
Dividing, sir.
Dividing అంటే the purpose of a section is to see how the interior is existing. If you cut a given layer or a given solid or a given plan, okay, how the situation, how the scenario at that particular intersection point exists is nothing but your section. Okay. So if I cut, assume that if I cut a line here like this. So how the scenario exists? If I remove the top portion, how the scenario exists at that position is nothing but the section. Sections, plans, and elevations are mandatory for civil engineers. For every plan, you will also be giving a section. You will be drawing a sectional line, and then you will be showing a sectional line. Then at the bottom, you will be showing how the section at that point represents. I hope this must be covered in your graphics. Not, we'll see again. But section is very, very important for us. Okay. Because it gives you a clear idea how the surface is existing at that point. Okay. So the process of tracing contour lines on the surface of the earth is called as contouring. This is already done. This is the purpose of contouring. What is the main purpose of contouring is it is carried out at the starting of any engineering project such as a road, a railway, canal, dam, and building, etc. Okay. It is also useful for determining the most economical or suitable site. Okay. In the first example, I have shown you how much amount of earthwork excavation is required and filling is required. Okay. If you have a contour map of covering the whole area, assume that this whole area, okay, this is if you want to lay a road line, this is Saidabad area. Okay. So this is Sarur Nagar Cheruvu, Sarur Nagar Tank Bund, and or let me take a rural area. This is Masab Cheruvu, which is going to, which will be able to find when you are going to Ibrahimpatnam. This is Gurramguda area. So I want to lay a new road from Gurramguda to Kammaguda. So these are the two areas. I want to lay a new road from Gurramguda to Kammaguda. This area, this point, and I want to lay a road line between these 2 points. Okay. If I have a contour map, okay, what I can do, I can draw a line, right? I'll show you once. If I have a contour map and I want to lay a road from this area to this area is my requirement. Okay. So what are the various possible ways of reaching this point now? From here to here. I can reach straight like this. This is one more village, so I can reach from here to here. Or I can reach from here to here. Or I can reach from here to here also, right? There can be any possibilities, right? There can be a number of possibilities. If there is a feasibility of laying a road, we can go in anywhere, any manner. But how to justify or how to select which one is feasible? Okay. If I am going from this direction to this direction, okay, this is my road alignment which I am proposing. So I am laying this road alignment on this contour map, wherein I have a contour value. So from here, some values. Assume that here you have some value. Here is the contour. Here it is 530 meters is there. Okay. And here also you might have some other value. It's also falling under Here it is coming under 540 meters. Okay, assume that this is 530 meters and this is 540 meters. Now, if I lay this alignment line, if I lay this select blue color lo meeku edaithe highlight avutundo, that is my alignment for one, my proposal one. If I lay this line on these two contour lines and determine the section and determine the elevation differences, I can calculate how much amount of earthwork is required for filling and excavating. I can prepare a budget. Then I proposing a proposal two also. Okay, from here to here, if I do a new road line, what will be the amount involved in excavating and filling of the earthwork and all corresponding cost, and a third line and a fourth route. So if I have 4 to 5 different options of laying a road, and if I have a contour map, I can simply overlay all of them and calculate what is the amount of efforts that are required in completing the project. So out of these four, then I'll say that no, first option is the better, or second option is the better, or third option is the better with a technical report. Okay. So that is what is required. So what I want to convey is here it is 530, here it is 540. Okay. In between you are having 520 here. So what is happening here? 530 దగ్గర 530 నుంచి 520 కి వస్తుంది, 520 నుంచి 540 కి వెళ్తుంది. So how much area you need to fill at this portion now at 520? So in the second case, if it is only 510 or 520 and again it is 530 and 540, the amount of earthwork required will be less. So I can adjust within this area. But here, in order to raise the level by 20 meters, definitely it is not possible for me to fill the earth from the excavated one in the nearby area. I need to procure it from the other areas only. So like that, you need to do an analysis. You need to lay your proposed alignment on the contour map and determine what are the costs involved in each of the proposal, and then give a final decision, take a final decision and propose no alternate one is best or two is best or three is best or four is best. So that is the main purpose or main application of your contouring. Okay? So like that you can do for anything, either road network or rail network or a dam or a bridge. Many times you might have heard recently in the news, if the Polavaram is limited to around 41 meters, there is going to be less amount of water stored, but there will be a saving of public or inundation of villages. Okay, if you increase it to 45 meters, there may be more submergence, but there may be more amount of water storage. So all these analysis will be done only by the help of these contouring maps. Okay, that is a very high-end work which can't be covered in this, which will be covered as part of your higher surveying. But that is a major purpose of doing these contourings or doing this leveling operations. Okay. So to locate the alignment of a canal so that it should follow a ridge line, to mark the alignment of roads and railways so that the quantity of earthwork both in cutting and filling should be the minimum. Okay. And it is also used for getting the information regarding the ground, whether it is flat, undulating or mountainous, to find the capacity of a reservoir and the volume of earthwork, especially in a mountainous region, to trace out the given grade of a particular route, to locate the physical features of the ground, such as the pond, a depression, hill, steep or steep slopes. I'll just explain this with the figures. Don't worry. And the contour interval is the vertical distance between two consecutive contours. It's called the contour interval. For 1 is to 50,000 K, it is 20 meters. For 1 is to 25,000 K, 1 is to 25,000 topographic maps, it is 10 meters. But contour interval is purely dependent on the purpose of the project. Okay. If you want to prepare a contour interval of 5 meters for the purpose of a reservoir work or a road work, the cost will be around 100 to 200 times than the normal work. Okay. If you prepare a 20-meter contour interval for a house construction of a 2 BHK or 3 BHK, it is of no use because you will be having only one value in between. So depending on the purpose of your project, you need to decide what should be the contour interval. Okay. I'll just show these with figures. A series of closed contour lines on the map represent a hill if the higher values are inside. So this is a plan and this is an elevation. So you can see in this plan, At the center, you are having a 80-meter contour interval surrounded by 75 meters, 70 meters, 65 meters, and 60 meters. That is, if the contour value is increasing from outside to inside, it indicates the hill. Okay, 80 meters is more than 60 meters, right? Numerically also. Okay, so contour intervals increasing. If the value of the contour is increasing from outside to inside, it is called as a hill. And if the contour values are decreasing from outside to inside, it is called as a valley or a depression. You just compare these two ones. In this first scenario, what is happening? Just try to copy this here. In the first case, what is happening? You can see here 70, 60, 80, 75, 70, 70, 65, 60 is there in the second case. That is the outer contour is 80 and the inner contour is 20. But in the first case, you can see outer contour is 60 and inner contour is 80. So if the contour values increases from outside to inside, it is called as a hill. If it's a reverse scenario, it is called as a depression. So you can see here a small picture. Here outside it is 230, 240, then at the center 250, 250, 240, 230. So you can see the representation here, how it is happening. At this end, it is 230 meters at this end. As you are coming inside, the contour values are increasing. So what is happening to the topography? You are having a hump kind of thing at the center, right? This portion. And again, it is decreasing. For a valley, you can see at the outer end, you are having a 240 meters, then 230 meters, 220 meters, then again 220, 230, 240. So what is happening here? 240 నుంచి 230 కి వస్తున్నప్పుడు 220 కి వస్తున్నప్పుడు you are having an elevation decrease. So it is called as a valley. From these two figures, I hope you are able to understand. So if the contour values are higher in the inside, it is called as a hill. The contour values are less inside, it is called as a valley or a depression. Hello, I'm in a class. 11:30 minutes. May I know who is this? Okay. Yeah. I'll get it. Okay. So that is the difference between a hill and a valley. I'm repeating again. If the contour values are high inside, then it represents a hill. If the contour values are less inside, it represents a valley. You can see simply here in the map. Do you see any hills nearby our college? మన కాలేజ్ దగ్గర ఏమైనా గుట్టలు చూసారా? చూసారా చూడలేదా?
No, sir.
మన కాలేజ్ దగ్గర మీరు గుట్టలు చూడలేదా?
No, sir.
మన కాలేజ్ దగ్గర అంటే మన కాలేజ్ క్యాంపౌండ్ లో కాదమ్మా, చుట్టుపక్కల. చూడలేదా? If you go opposite in the opposite road of our college, you will see the hills which are available adjoining to the RCI area. ఎప్పుడైనా చూడండి కాలేజ్కి వచ్చినప్పుడు ఒకసారి. Okay. This is Devatula Gutta. You can see here the name. This is our college. MVSR అని కనిపిస్తుంది కదా. Okay. This is our college. Then you have a, if you go opposite to that in the road, you will be having many hillocks here. Okay. So this is one hillock. This one. Then this is one more hillock. You are having many hillocks here. So you can see now, let's take this example. What is the value you are able to see here? 550 meters are you able to see?
Yes, sir.
What is the value here? 638. You are seeing a triangle portion, right? Okay. So the elevation value you can see here. Here there is a value of 600. Here there is a value of 600. Okay. You just follow this 550 contour like this. It is following like this, like this, like this, like this. Then at the center, if you come, it is 600. So definitely these contours may be either 560, 570, 580, 590. Okay. Because the contour interval is 10 meters. It is a 25K map. Okay. So this outer contour is 550. Then after this contour, there is only one contour here. So this contour is 560. This is 570, 580, 590. And this is the 600-meter contour interval. So what is happening to this area now? The contour values are increasing from outside to inside. So this is called as a hillock. Here there is a name, so you are able to identify, but based on the contour values only, you need to identify whether it is a hillock or whether it is a depression. And I think we don't have any depressions here to represent because there is no valley, such kind of thing. I don't think so. You'll have something. Okay. So we have only elevations in this map. We don't have any depressions in and around area. I'll show you the next map, then you'll be able to identify. Okay. But keep that point in mind. And the next one is the contour line crosses ridge or valley line at right angles. If the higher values are inside the bend or loop in the contour, it indicates a ridge. And if the values or higher values are outside the bend, it represents a valley. You just see these two figures. Okay. These are the contour values of 90, 100, 80, 70, and 60 meters. And this is the ridge line. Okay. The higher values are inside the bend. You can see here. E line E. This is called as, this is the line. This is the contour and this is the bend, right? So if higher values are inside the bend, it indicates a ridge. Okay. If higher values are outside the bend, it indicates a valley. From 100 to 50, there is an elevation decrease. So obviously it becomes a valley. From here, you can see there is an increase from outside to inside. So it represents a ridge. What is the purpose of this ridge or valley? Any wild guesses? Why we need to identify where is the ridge line and where is the valley line? Ridge and valley are very important from watershed point of view. Okay, a watershed is nothing but whatever drain that is following in a particular area will be passing through only single outlet. So a ridgeline deviates or differentiates two adjacent watersheds. Here you can see there is a value of 50, 60, 70, 80, 90, 100. Whatever water that is falling towards the left hand side will try to drain only towards the left hand side. It can't cross the ridge line and come towards this line. Similarly, whatever rain that is falling towards the right hand side can only flow through the right hand side, not to the left hand side. That is the advantage of a ridge line. Okay, I'll show you again this also with a map. See, this is a drainage map. Okay, this is the drainage. You can see. Assume that now the rain is falling over this point. Okay, and this is the ridge. This is the watershed boundary. So this is the ridge. This green color boundary, what you are seeing is the ridge boundary. Okay, so whatever water that falls in this area on this green portion will only drain towards the downward side towards the Sarvanagar tank. That is identified using this drainage pattern. ఇక్కడ పడుతున్న water that is flowing like this, like this, like this, and it is going to join the Sarvanagar tank. But you can see here at the bottom immediately you are having one more drainage line. Okay, the water which is falling here is traveling in this direction and joining a bigger drain. So the water which falls here can't go towards the green boundary. It can only come towards this boundary because there is a ridge line existing in between this. That is, there is a variation in the elevation values from here to here. Okay, Here again it is 550 meters. You can see from 550 meters, then you'll be finding out another lesser value. See, 550 meters, 560 meters, you're having a higher value. Okay? Then 610 meters. So the water whichever is falling in this area from this area will definitely flow towards this side, and water which is falling in this area will definitely flow towards this side, towards the Sarunagar tank. So ridge line is very important in delineating the watersheds which are used for the developmental activities. Whatever water that is falling in this area will come and completely drain into or fall into the Sarunagar water tank. Whatever water that is falling in this area cannot come in this area, cannot come into this area because of the natural ridge line existing. అంటే మీకు ఎలా ఉంటుందంటే so this will be the scenario. ఇప్పుడు ఇక్కడ పడుతున్న వాటర్ ఇటు పక్క వచ్చే అవకాశం ఏమైనా ఉంటుందా? అజ్యూమ్ దట్ యు ఆర్ హ్యావింగ్ ఎ రెయిన్ఫాల్. ఇక్కడ పడుతుంది ఏరియాలో వర్షం పడుతుంది. ఇది కిందికి వస్తుందా ఇటు వెళ్తుందా?
కిందికి వచ్చేస్తుంది సార్.
ఇక్కడ పడ్డ వాటర్ అయితే పైకి ట్రావెల్ చేసి ఇటు రాదు కదా. సిమిలర్ గా ఇటు పడుతున్న వాటర్, ఈ పాయింట్ దగ్గర పడుతున్న వాటర్, అజ్యూమ్ దట్ దిస్ పాయింట్, ఇక్కడ ఈ పాయింట్ దగ్గర పడుతున్న వాటర్ ఇటే వస్తుంది కానీ ఇటు రాదు కదా, ఎందుకంటే దిస్ పోర్షన్ ఈస్ లోవర్ ఎలివేషన్ దెన్ కన్సిడర్ టు దిస్ పోర్షన్, రైట్? ఓకే, సో దట్ ఈస్ ద డిఫరెన్స్. A ridge line as well as a valley line are very very important in determining what is the watershed boundary. Okay, similar case. ఇటు పడుతున్న వాటర్ అంతా ఇటే వస్తుంది, ఇటు పడుతున్న వాటర్ అంతా ఇటే వస్తుంది. ఓకే, ఇటు నుంచి ఇటు రాదు, ఇటు నుంచి ఇటు రాదు. And the next one is contours cannot end anywhere but close on themselves either within or outside the limits of the map. A contour is a closed one. You can't have a contour just like this open and ending. Okay, within the map you might have a open contour, but always a contour is a closed boundary. It has to come and close somewhere like this. Okay, it can never be a open contour. In your map it may not close, but I'll show you one example again for that. You are able to see this line, a black line. This is a 540 meter contour. Okay, 540 meters is coming in this map like this for me. Okay, but it is crossing my limits, my map limits. It is going out and again coming in. Okay, so like this, it may not close in your map, but it may close in the adjacent map also. But by default, a contour should close on itself. A 550 meter contour interval cannot join a 551 meter contour interval or 560 meter contour interval. A 550 contour interval should join with only a 550 meter contour interval. Okay. Yeah, it's 11:01. I'll stop. I will see tomorrow. Please give me your attendance. Oh, 50 students. ఏంటి విచిత్రం? How come 50 members? Number 1.
Present, sir.
2.
Yes, sir.
3.
Present, sir.
4.
Yes, sir.
5. 6. 7.
Yes, sir. Present, sir.
8. 8.
Yes, sir.
9.
Yes, sir.
10.
Yes, sir.
11.
Present, sir.
12. 13.
Present, sir.
14.
Yes, sir.
15. 16. 17. 18. 19.
Present, sir.
20. 21. 22. 23. 24. 25,
Present, sir.
26,
Present, sir.
27,
Sir, 24 present, sir. Mic
27,
mic problem ఉంది, sir.
27, 27,
Yes, sir. Yes, sir. Yes,
28,
sir.
Present, sir.
29,
Present, sir.
30,
Present, sir.
31, 32,
Present, sir.
33,
Present, sir.
34,
Present, sir.
35,
Present, sir.
36, 36, 37,
Present, sir.
38, 39,
Present, sir.
40, 41,
Present, sir. 41.
42,
Present, sir.
43, 44, 45,
Present, sir.
46, 47,
Present, sir.
48,
Present, sir.
49,
Present, sir.
50, 51, 52,
Present, sir. 51.
52, 53,
Present, sir.
54, 55,
Present, sir.
56,
Present, sir.
57,
Present, sir.
58,
Sir, yes, sir.
59, 60, 301,
Present, sir.
302,
Present, sir.
303,
Present, sir.
4,
Present, sir.
5, 6,
Present, sir.
7,
Present, sir.
8,
Present, sir.
9,
Present, sir.
10,
Present, sir.
311. Okay, thank you. Bye for the day. We'll meet again on Thursday. Okay. And one more thing, Subramanya sir will not be taking classes for next 10 days. Your overview. Okay, sir will take after the time.